The universe is calling me. It speaks both day and night. It's full of dark and light. And I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space, fields and forms, math and voids. It all sings with one voice. It's boundaries set, foundations laid. Sound was heard, matter made. Solar systems from afar. Names and numbers for the stars, and I've heard others call from light years away, and they're real and they're here. Space and time are instantly clear. Planets spin, grids in place. We can travel through space. It's the Lord's.
Hey everybody, welcome to SkyTour livestream. It is, who am I? Oh yes, I'm Mark D'Antonio. Nice to see you all here. And I have, of course, the infamous Daryl Mason. Hey Daryl, how are you?
I'm good, thank you. How are you, Mark? Hello, everybody.
I'm doing good, thank you. I'm doing good. And we talked earlier, and you said that you had potentially 100-mile-an-hour winds in Boulder coming in.
Yeah, they weren't that bad here. They might have been 60 miles an hour here, but Boulder's famous for being one of the windiest places here in the state.
Wow,
And they were calling for 100-mile-an-hour winds.
that's pretty crazy.
That's Colorado.
Yeah, yeah. Well, I set up here. The reason I asked you about the wind is because out where we are in the desert with SkyTour Sonora, and we have, oh, look at that plane flying by. A plane flew right over Sirius. You see that?
Mm.
That's pretty cool. And it left a contrail too. That's neat. As we're talking. Here at SkyTour Sonoran, the wind looks like it's going to be nice and easy tonight. It's not going to be that big a deal for us, I think. So that's very helpful. If you wonder what the chances are that something will fly right through the exact image you're looking at, it's actually not a very good chance. But we did have a jet fly through, and it left a brief contrail. Lack of contrail indicates that it was actually pretty dry up there, which is what you want.
I once had a solar filter on looking at the sun after work one afternoon, and 747 flew right in front of the sun. You could see the shape, the
front end, yeah.
Right.
That's cool. That's really cool. Okay, I'm going to take this up to 1 second and then readjust. So it's going to get bright for a second and then it should readjust. So let's do that. So there's 1 second and then here's the adjustment. Okay, good. Yeah, so this is serious. I'm just putting that on there for now just to get us locked onto something. Tonight we're going to be checking out galaxies, and we're going to be looking in Leo and Coma Berenices. It's going to be kind of nice. We'll explore the beauty of the galaxies out there.
Don't forget Ursa Major.
I won't forget M81 and M82 in Ursa Major. Yeah, because that's way up north. We'll be digging out our northern coordinate systems and getting everything in there as well. As you can see,
oh, Izabela.
Isabela's with us. That's good. So we didn't have to call her tonight. I like that. Izabela asked us to call her the last time we went on. And I thought that was pretty cool. So let me just say who's here right now. We have some folks that haven't been here before and some that have. Stuffy's with us. How you doing, Stuffy? Papa Tom, Tim F. Woohoo, you're the first. Okay. Nice to see you guys. Michael Hendricks with us. Daisy and Zoe Amethyst is here. And yeah, we're going to talk about the eclipse tonight. Between now and Eclipse Day, I'm actually going to do another stream, which will be a presentation on the eclipse and what to look for and everything. So it's going to really be a nice in-depth view of the sun and some of the physics that the sun goes through, but it's all going to be at a level everybody can understand. So we'll do that probably tomorrow, actually, because Monday morning I have to go on InfoWars for a show. I was on Clyde Lewis day before yesterday, I think. Yeah, days all run together, but it'll be kind of cool. Let's see, and we also have this Daryl guy who keeps showing up in chat. I don't know who he is. DPFX is with us. How you doing, man? And
Lane is here with Daisy and Zoe.
I didn't see that. Did they make the announcement?
Yes.
Okay. Oh, I guess I'm getting to it now. Hey, Lane. Lane, I hope you like astronomy because we're going to be doing more of that tonight. And Weather is Crazy is with us. How you doing, man? What's up, Weather? Back from the shadows. I'm glad you are coming out of the shadows to hang with us. And Ghost Jazz Kill, how you doing? Jazz K Hill.
Papa Tom wonders if your volume is low tonight.
No, it's not that low, but I can actually speak closer. So it's possible that I could give a little extra oomph to my voice. So let me try that and see what happens here. Maybe this is a little better right now. So, and I also want to say to our friend Corey, I tried to find closed captioning in YouTube and I can't find it because he asked for closed captioning and I wanted to put it on for him and I cannot locate it. So I have to figure out what's going on there. And of course we have Curtis Horn with us. What's up, Curtis? Maybe I'll see you at Contact in the Desert. Let me know. Mr. Spiritus is with us. And let's see now. Luis Rodriguez is here with us. Nice to see you, Luis. And so far, that's it. And of course, Izabela. Ta-da! Isabella's with us. All right, so let's check out how Sirius looks now. As you notice, the sky behind the telescope up there is getting a little darker. And so what we might try to do now is I'll back out of this. And we're going to head north and check out. Okay, we're going to look at a couple things in here as well. But right now, while we're waiting for the sun to go away fully, I would like to go up to the constellation of Cancer and check out another really cool object, which is the Beehive cluster. We've looked at this before, but we'll do it again tonight. So why don't we head there now? You'll watch the telescope move right there. There it goes. There's a little bit of a lag in time before the screen changes. Okay, and we should see the cluster come into view. There it is. We are also changing this entire mounting system that you see here for the telescope. This is called a fork mount, and we're changing it to a German equatorial system, and it's going to be a mount called the Skywatcher EQ6 Pro. And we're going to use this same exact mount for SkyTour Benson as we are for SkyTour Sonoran. And so we'll have identical control mechanisms for Benson and for Sonoran. So that's really important to do. So this will make it a lot easier for us to show things to you in a way that's consistent, because we're planning on having two screens up at the same time, or at least flip-flopping, alternating, because screen real estate, of course, is huge. And so you'll see the close-up view from SkyTour Benson, and you'll see the wide-angle view from SkyTour Sonoran, which is what we got now. Okay, so our size of our field here is also reflected in our planetarium program here. All right, if we go here and look at this location where we are, we zoom in, you'll see that red square. That's the size of our field. And if you read along the bottom, it says it's 1.5 degrees by 1 degree in height. Just as a comparison, the moon is 0.5 degree in diameter. All right, so basically 3 moons across and 2 moons tall, full moons. All right, so that's what our sky looks like here. I'm sorry, our field. Right, so that's that gives you kind of a rundown. I want to say hello also to Keith Evans, who's joining us. Hi, Keith. Not sure if you've been with us before. If you have, welcome back. Donald Kunzer's with us. He's been with us. He's been with us for a long time. I will move this down. Now, we are using Starlink, and we're in a low bandwidth zone for Starlink, but what's happening is that Starlink actually seems to be performing pretty well most of the time. But, we'll see how it goes. We do get delays from time to time. Okay.
When we see M44 here, the Beehive, it's also Messier 44.
Praesepe.
Also called Praesepe. The Beehive was actually known to the ancients. It was that big and obvious in a dark sky. They named it the Praesepe, which means the manger. And I had to look up what exactly a manger is. Just like the Christmas Carol, of Babe in the manger or whatever. It's the trough they feed animals out of.
Yeah.
Where they stuff the hay, I guess.
Yes, sirree. Okay. That warning was because our all-sky cameras converting from daytime to nighttime. And so it takes a couple minutes for that to catch up. Science Bob is with us, and Alicia Vieira's. Hey, how are you both doing? Alicia is well placed for the eclipse coming up Monday. And Science Bob, I don't know where you are, so I'm not sure if you're well placed. We're gonna have 92% coverage here. I was not gonna travel this time because I've seen a amazing eclipse before, and I am not going to spend time trying to drive through the madness that I know occurs during eclipses.
Yeah.
So they're expecting 1 million people in Stowe, Vermont, for instance. I'm in Connecticut right now. Telescope's in Arizona. And no, I can't use this telescope to look at the sun, but if I did, we'd only see a very partial eclipse from there. And so people that travel to the totality location are going to be treated to the sun's corona, whereas the rest of us won't see the corona. We'll see a very bright sliver left over. I do have a solar telescope here, and it's the solar telescope that, with modifications, is going to become our East Coast Solar Telescope Observatory. So we have SkyTour Sonoran, which is this one here you're all looking at. We are broke ground for SkyTour Benson, and we're buying equipment this week. Then SkyTour East is going to be a solar observatory. And it's going to be a much simpler setup here than it will be out there, because out here it'll be remote, but it doesn't have to be as bulletproof as the others, because we're looking at the sun only here, because the telescope is only used for the sun. It can't be used for anything else. So I just got to get a mount, and there's one out there that I'm going to get. And that mount, its job is simply to find the sun and center on it. That's all it does. And that's what we're going to get. So E-Man's with us. Hey, E-Man. E-Man's going to be 90% where he is. We're 92 where we are. You know. And Stan from Two Rivers Observatory is here. And he says, thank you. He's telling me what to do here. If you go on YouTube Studio on the left side. Okay, I'm going to try that, folks. If you just bear with me for a minute, I'm going to see where I am. Okay, YouTube Studio on the left side. He says, click on subtitles. Oh, there it is. Okay, there's subtitles. All right, and now that I click on subtitles, I'm not sure what to do now. The subtitle shows my videos. It doesn't show. I have to do live closed captioning. I had a request from my friend Corey here, and I can't see that. Well, anyway, let's start this going here. I like to test our night by doing a photo. This will be 20 seconds. I'll make it 12 seconds. That's 12,000 milliseconds. That's why I put 12,000 in there. And then we're going to say go, and you'll see our yellow bar over here. And we'll do the live stack. And this will give us our amazing view in just a second. If there's no wind, we won't have any issues, and we'll start getting our images, and we got them, so we're good. We're only getting 8.8, so I'm going to drop that down. Don't worry, folks. Our data is there, believe it or not. I'll go back here, and let's line up all of our curves. There we go. And now let's do the processing. And boom, there is, right there, Persepi. You can see the red fringe. That's the sunset colors that are leaking into our image. And so we'll have to deal with that just for a few more minutes. Okay, so now these are our curves. All right, we have our red sunset fringe that you see there, and that's why we take this picture, to make sure that it goes away. All right, sorry about the squeak.
Izabela says closed captions. You check closed captions in stream settings.
Yeah, I see. The stream is being created automatically, so I have to go in after the stream's been created, and if I can find that location, I'll do it. All right, so what I'm going to do right now is I'm going to I have a chat running here, a separate chat, which I need to use here for a second. Let me see if my friend Corey is here. No. Well, let me just say it to him. All right. Ghost Jazz Kill asks if you can really phone home with a a seeing spell or speaking spell. E.T. phone home. Elliot. That movie was really quite interesting to me. Yeah, see our red? That red is going to give way to black. So what I'm going to do is clear. All right, and start again. And when we get the next exposure, we will see whether it's as red. And judging by how red it is, it'll tell us what we can do. So let's do this. Still got a little red. Okay, so I'm going to take this and move this up here. It's less red though. We'll wait it out. A few more minutes. We have to wait a few seconds. Roy Batty says, sorry, just got here. Are you going to be filming the April 8th eclipse? Unfortunately, I don't have a camera to put on my solar telescope. Or yes, I'd be streaming it. So I won't be able to stream the eclipse from here. But there's many other places that will. High Point Scientific's probably going to do it. You know, and that'll be really good. I trust High Point more than the other facilities, the other places. Jane Murdoch, what's up? How are you? C&D Boy is here as well. Hey, that's cool. Let's see, I saw something that he... let me see what C&D Boy said. Oh, he says, you're on TV and on my computer live. Oh, so you put the stream... Oh, Proof is out there. Oh, the show. Okay. Okay. I thought you were actually saying that you put us on your TV. Okay. That's very cool. I'm glad that you like that show. It's one of the few shows that I was willing to participate in because they don't try to monkey with my analysis. They don't try to make me say things that aren't true. And that's very important. For those that don't know, there's a show on History Channel called The Proof is Out There. And for about 4 years now, I've been their photo and video analyst for all the stories that have photo and video evidence. And, shows, they have to, the bottom line is they got to, sell advertising, right? So they got to be attractive to people. They got to bring in all kinds of people. So it's very tempting for some of these shows to try to convince you to say something that isn't true or, is sort of on the border. Like, if I see a bird and it's really a bird and I see that it's a bird, some shows might say, well, can you say this might be a very cool UFO when you know it's a bird, for instance. And I've never had the folks, the producers and the writers for Proof Is Out There ever tell me to compromise anything that I'm going to say. They want to know what I have to say, and they run with it, So I think that's pretty cool. They're very nice of them to do that. They didn't have to. Okay, when I correct here, we should be able to get rid of this red. We're not able to quite yet. Well, let's just see how much is there. But the Beehive is beautiful, guys. Look at that. You'll notice that these are the stars. You'll notice that there's red stars in here, too. These red stars are of the same apparent brightness, roughly, as some of the other stars. They're actually a little brighter. And that's because they're probably bigger and luminous giants, luminous supergiants in the cluster. So I think Daryl might be able to look that up while I'm doing the other 5 things at once I'm doing.
I'm sorry, I was doing things too. Look up what again?
What stars in Praesepe are actually stars that belong there that are the red giants? Stan, you mentioned about automatic captions. I have that set. So I guess our friend Corey can do that too. Rocket City's with us. Hey, Rocket City. Good to see you. So yeah.
Messier 44 is home to 5 red giant stars and a handful of white dwarf stars.
Okay.
244 also contains 1 peculiar blue star.
I want to find that. Do you have a map? Do you have a finder for where it is?
Looking.
Oh, well, get its magnitude first of all, because I might have
magnitude of what?
The blue star, if you have it. Rocket City, heading for the eclipse. You're a braver person than I am. You might get to see it, but you might get stuck on the side of the road to see it. Because there's going to be a lot of traffic. It's going to be horrendous traffic on the interstates. I guess it's worth it if you've ever seen a total eclipse before. I have. This is the big Beehive, Izabela. She asked if this is the little or the big Beehive. I should have put the name up here. This is Messier 44, known as the Beehive cluster. I'll just put OC because it's an open cluster. Okay. Hey, Ralph Wooden, how you doing, man? Ralph's in North Carolina. And by the way, guys, Ralph is an exceptional astrophotographer. He's one of the best. And I'm glad he's joining us. Oh, why is that up? Sorry, I didn't want that up. So he's quite a good photographer as well. Takes beautiful imagery. You notice that we have some dropped frames here, but that's fine. The last few have been dropped. I won't compromise on my star roundness, though. That's what the full width half maximum filter's doing for us. So I would hope to see that come down. It might be the post-sunset winds that start up. Ralph, maybe what we'll do, Ralph, if you want, we can have you on board with us one night as one of the exceptional astrophotographers out there. You can join us on the air live for one of our streams. If you're up for that, let me know. And then send me a Skype or send me an email, and you can find me actually on skytourlive.org. In our contact form if you want, and then you could send me a message telling me your details, and we would have you come on, because you do some great work. Our photography we do is, for the masses all over the world. We actually do this stuff, our next telescope, the one for SkyTour Benson, that's going to be a telescope with narrowband imaging and imaging like this, okay, as well. And we're also going to have a spectral grading on one of the filter wheels, so we can identify spectra of some of the stars. And then we can do spectra one night as well. I also have a spectrometer behind me in a drawer, and that spectrometer is going to be one that becomes a real feature. I can see that we're doing this. So what I'm going to do is I'm going to get out of this, because we are rejecting too many, which means that we're probably getting a little wind out there right now. That's the only thing that would be causing this right now. And usually
I
after
learned something.
What's that?
The age and the proper motion of the stars in the Beehive are the same as those of the Hyades, suggesting they may share similar origins.
Interesting. Actually, if think about it, Daryl. From a certain distance away in a certain perspective, Praesepe and the Hyades might be somebody else's double cluster.
Yeah.
Without Aldebaran, of course.
Well, Aldebaran's not really a member of the Hyades anyway. It's a foreground object.
Yeah, for us it is, and so you have to illustrate that so people realize that it's way up in the foreground. And as you go to the Hyades, Aldebaran's going to pass you, and you're still going to have the Hyades in the distance. Yeah. All right, Ralph, I see that he says I'll do that. Shot M88 last night, and I'm currently imaging 2366 because it's galaxy season. Yeah, that's what we're doing too. We're waiting for it to get fully dark, and then we will do that. That's good. Okay, so we're going to just do what we can here, and I'm going to do this now and do this and see how red the background is. Aha. Okay, that's actually good to see. We're actually darker, so I'm going to clear this now, and let's see if we get our next exposure in for 12 seconds. Alice Pooper is with us. How you doing? It's always so much fun to say that name. All right, let's see here.
Another thing I didn't know, I think it's the two bright stars to the left of the cluster as we were looking at it.
Yep.
Those represent two donkeys, two asses, so to speak,
Okay.
eating from the manger.
Really?
And the donkeys were actually famous in mythology.
Oh. Okay, notice how we're not
And
getting in
I
the
closed the
red
window. Two famous mythological figures rode them into battle.
there. Huh.
Go
So
figure.
which stars you talking about?
The two left of center. There's one
Like one
toward
of the
the
red
top
giants?
and one toward the bottom.
Like this
No,
one?
farther out. I think it's that one and the one below it.
This one and this one?
Yes.
Interesting. Wow, well,
Uh,
that's pretty interesting.
The one that's down about 8 o'clock from the center.
Oh, maybe this one?
No, to the left.
To the left, this way?
Well, sorry, I was looking at the YouTube screen. That one,
Oh, okay, so this one.
yes.
This
I
one
believe.
and maybe this one.
I think so.
Okay, cool.
And I don't-
Stan
don't
asked
remember
about...
what else you asked me.
That's
There
okay.
are five red giants, and I don't know which one is the blue one.
Yeah, if we actually go look, well, we have one red giant here. We have one here. Okay, we have one here. That's 3. There's a 4th one that's buried in here. Okay, and there should be another red giant here. Is that it? Is that? It looks like it's red.
I think they said 4 of them are K stars and 1 is the G star.
Oh, okay. All right. Well, these are our stars, and of course we're using our telestrator that we have for doing this kind of thing. Nice. Okay. All right. So
I
for
closed
people,
the tab. Sorry.
oh, that's okay. Don't worry about it. So for the people that actually are here that have never seen what we do, I'm going to just point out a few things to you. Okay, this over here, this is the telescope controls, north, south, east, and west, and a few other things. This is the telescope computer right here. Right now we see nothing because the screen blanks out after a few minutes. This is the telescope in the SkyTour building out in Arizona, this desert. Here's another view of it. This is some guy that just talks too much. Okay. This screen will come up often. This is when we stack our images. Okay, we do active live stacking. So we're actually building image sandwiches of these these objects, and by doing that, we remove a lot of the noise in between, and they look better and better and better with every exposure. This over here is the exposure control system and the camera control system in here, right? Of these things here, this here is the exposure, and this here is the gain. These are the 2 most important elements of the camera here. So we have the amount of time and the sensitivity of the system, the sensor. So this gives us everything that will help us provide you with amazing imagery that ends up being free. So when we actually start taking actual photos of this and start sharing these with you, we're going to save these, and these are going to go out to our server, which is, of course, way out. It's going to go up to space and come back down and end up at our server that you can find here at skytourlive.org. Okay, so you go to skytourlive.org, and at skytourlive.org you'll find that there is a panel, if you scroll down, that says take me to cool pictures, and you go check out these really neat pictures, and every one of them are free for you to download. And if you want to support us, we'd love to have you support us. Okay, we really would love to have new Patreon members, and that will come with benefits, because if you go into our higher tiers of support in Patreon, then you have available to you high resolution finished processed images that we put out there. And Izabela in the chat religiously, let me tell you, that lady is absolutely really special. Okay, she does amazing stuff for us. And just be quiet, Izabela. I'm giving you a compliment. She's not talking. I'm just imagining her saying, "Oh, stop it," right? She's actually very nice, and she's a fantastic artist. So thank you for putting that out there. And show her some love, because she spends a lot of time doing really cool videos for us and other things that she doesn't have to do, but she does it because she's passionate about SkyTour live stream as we are, and gotta love that, And then we have Daryl, who puts in his time to hang out with us as well, and Daryl's not getting anything out of this, where none of us are making money on this. So it really is about the passion. So we love what we do, and so we're bringing it to you because we love this stuff. All right, so here's a nice photo. We had 24 shots, only 5 rejected. So you see that windy bit? It kind of went away. As soon as the desert winds, they kick up at sunset, they just go away after a little while or in a few minutes, and the telescope sticking way up is like a big flag blowing in the wind. and it looks okay right now. So I'm going to save this. All right, I've got Beehive up here, open cluster. I kind of spelled one little thing wrong. But by saving this, you'll see that it's going to come up with a green line that says this FITS file has been saved. That's an astronomical file format. You don't have to worry about that if you don't want to. But if you want to, you can take it down. It's the raw file. And then you could process that all you want. And now we have the ping file. This is the PNG. This is the file that you can just grab off the server, download it, look at it. And we're still getting some sunset color in here, obviously. And that's going to go away over time. And it's going to take us, it's 8 o'clock out there right now. So we're getting close to having no sun in our view. And the last part of everything we do is this right here. This is our planetarium view. We control the telescope from here. We don't have to. We actually have several ways, 3 ways we can control the telescope and drive it to different objects. This is Cancer, and this is the crab. You can see when we bring on the mythology imagery, there's Cancer the crab, right? And it's to the left of the Gemini twins. And I figure, right here, right, this is Castor and Pollux, okay? Castor and Pollux. And then we have this beautiful object down here, which we'll go to while we're here and check it out. And we will see some gorgeous, actually, I don't want to ruin the surprise for those that haven't seen it. But we're going to do a short set of exposures on this guy right here, just so you can see it. And so what I'll do first is I'm going to come out of here. I'm going to close down our streaming. I'm sorry, not stream. I'm going to close down our stack. And I am going to go back to our nice nighttime enhanced view here, so people can see. This is the live view right now. And then we are going to head to this next object here, which is going to be the Rosette Nebula. It's going to be one of the last times we're going to be able to see it, because it's, as you can see, that's past the meridian. It's starting to go down toward setting. And it's going to be down a little bit low before you know it. So we want to catch it before it does. And so we're going to check it out. And there's the cluster in the middle of the Rosette. You can see a nebula in here, kind of faintly, but it's there. And we'll center it up and take a picture and show you what's really going on in the universe. There's an awful lot happening out there. And thanks to this telescope, you're going to get to see it. Judy's with us. Hello, Judy. Nice to see you.
Cluster NGC 4144, if I remember correctly.
This one?
2144?
2144, yeah.
There you go, yeah.
Yeah. All right, so I'm going to move this over a little bit. And then bring it up a tiny bit. Sorry to make you guys dizzy, but hey, the telescope's getting dizzy too. Okay. All right, so from this position, we're well placed to do a really nice image. I'm going to just take us a little bit more over, just a tad. There we go. Judy asks if I'm going to cover the eclipse. I can't stream it, Judy, because I don't have the solar observatory ready yet. I tried. The camera's not here in time, unfortunately. I guess there was a hell of a run on these cameras. But it's a special dedicated camera for doing this kind of observing. I have the solar telescope, but I will be doing, probably tomorrow, which is Sunday, I'm probably going to do a live stream that covers the eclipse and discusses a lot about the sun, I actually did this to a packed house the other night, and it went over very well. People really liked it. And if you know me, you know that I always give more information than people ask for. So you'll be stuck with that. Just kidding. Okay, if we watch here, we're searching, and now right up there it says searching up here. Now we're getting our numbers showing up, which indicates that we're guiding in right ascension, which is east-west, and declination, which is north-south. So now let's do a really cool photography foray into this beautiful nebula. And I'm going to make this a 25-second shot. And in 25 seconds, we're going to see details that would take many minutes to capture. So here we go. Watch our yellow progress bar down there. Okay. And then we'll start the stream. I'm sorry, the stack. So the stack is going to have the M44 left in it. And of course we have this is up high right now. That's another histogram, and we're clear. And let's make sure that this comes in. We're going to go to our full width half maximum filter. If it's red, it's not ready. The stars are too big. It's green. Oh yeah, look at that. Oh yeah, look at that. This is going to be now this isn't color corrected or processed yet. This is the raw shot. All right. But the nice thing is that we can color correct this right here on the spot. And so we'll do that. So I'm going to color correct it right now. We're going to bring all our color curves underneath each other. And you'll see now the actual color show. All right. And then you'll see it right there. And then I'm going to do a little processing on the overall curves here. This white curve represents the average of the red, green, and blue curves. This is the black level, this one. And as we move it closer to the peak, it makes space as black as it can be. And then this one is the white level. As you move it over, it starts to accentuate the detail that's hidden in the dark there. Okay. This is what I think is one of the most beautiful objects in the sky. And so as the Rosette Nebula, it's called because, well, it kind of looks like a rosette, doesn't it? It looks like a rose. You know. So,
Mark,
yeah.
Izabela has a question, and Stan at Two Rivers has a question for you.
Okay. First thing I'll do is I'm going to get rid of the color noise. You'll watch the image immediately get better. There it goes. And then I'm going to turn on unsharp masks to dynamically sharpen detail. Now you can see it. Okay. Stan says, what software do you use for the telestrator? It's built into my remote access software for the observatory. I connect with a remote PC. And Izabela's question, where's that?
A little higher up.
Okay.
She says, hey, Mark, will you capture it on the all-sky camera, the eclipse?
Oh, I don't know if I can get the exposure down low enough, but because it's not going to be, it's in Arizona, so the all-sky camera is only going to see like, what is it, like 60% or 50%? It's not going to be, it's going to be a partial out there, a very serious partial. So I'm not sure we can do that. I've tried to cut it down so I can see the relative disk of the sun, but without without having like a stack of neutral density filters to drop that glow, or even a solar filter, the all sky cam would be out of luck.
Probably the image scale. I mean, you'd never be able to see the any crescent phase of the eclipse anyway.
Well, I mean, it is half a degree. So it's possible that we'd see a tiny little dot of it, but because it's actually a higher res camera. The previous all-sky camera certainly wouldn't have been able to see it. And let's go look at the all sky right now, actually, while we're here. All right, here's the live view right now. Here's the winter Milky Way right here. Here's Orion. But don't take my word for it. We can turn on the constellations. Okay, and you can see Orion right here. There's Jupiter out here. Castor and Pollux. Capella and Auriga. Leo right here. There's Leo. Oh yes, and this will be something you'll be able to do yourself when we actually get this live on the website. And what will happen is you'll be able to, for instance, when we turn on the constellations, you'll be able to hover over one of the Messier objects, and when you do, you'll see its picture come up. All right, like this. And then if you click it, it'll take you to wikisky.com, and you'll see a big write-up on it. And so you can literally explore the sky using the all-sky camera, which is really cool. The other thing you can do is look at the time lapses. All right, so here's a time lapse. Now, this is the time lapse from the other day. And so you can watch clouds go over. And then I'll just jump ahead and you can see the nighttime sky as the time goes on. The time is given up there. You can see it pass by.
It's a bird. It's a plane. It's bird poop.
It's Boeing parts. Yeah, and so yeah, it's bird poop indeed. So this day was actually, you can see satellites going over the whole time too. But I think on the 3rd, we actually had a really interesting thing happen. Okay, and I'll show you right here. You'll see it quickly. A bird lands on it. I put this on. You can see bugs. It came and went so fast. But then nighttime shows up. All right, and there's nighttime bugs flying around, landing on the dome because the dome is warm. Because I'm kind of heating the dome for moisture issues. But then we see something really cool happen. And it happens just after midnight. I think this is the one where we're going to see it. All right, so that's a satellite that went over. All right, but now, as it gets to past midnight now, look at that. Did you see that just went by? That's something that shouldn't be there. Because after midnight, low Earth orbiting satellites don't get illuminated. But that was a low orbiting satellite. Why would we see it when the sun is directly behind us in this image through the Earth? How could we see it? And that's pretty strange that we did see it. Really, really odd. But that's our amazing all sky camera, much higher resolution, full color. At 4 in the morning, the summer Milky Way comes up. I've been looking at it, and let me tell you, it is just outrageous. You can see the colors of the nebulae. You can see the North America Nebula and the Pelican. You can see the Sagittarius star cloud in full color. It's really, really nice.
It was Han Solo doing the Kessel Run.
And you'll see Han Solo doing the Kessel Run under 6 parsecs, a sentence which makes absolutely no sense.
Yeah.
Hey, Mr. Django. Good to see you. How are things in Belgium? James Hyde's with us. Hey, James. Well, let's see. Izabela, you don't have to watch it on. Well, I guess you have to watch it on Stellarium because I can't stream it. High Point Scientific's probably going to stream it. And I give them kudos. Star Arizona's not going to stream it as far as I know.
Somebody said earlier, of course, NASA's going to be doing a live stream also.
Yeah. Okay, we're going to call this the Rosette. Okay. Now we've got 19. We're going to go one more exposure, and then we're going to go to the next object. Go ahead.
Imagine somebody set up a network of solar scopes, whatever, along the eclipse path where you could watch it live, but over and over and over again.
Yeah. Yeah. Actually, that's effectively what's going to happen, I think.
Yeah.
James Hyde says that in his area he might see a double diamond ring. Are you not quite in totality, James? Where are you? Here we are at 20, so I'll save. And save exactly scene. I forget where you are, James. You told me before. He's right on the edge.
Right on the edge.
Yeah. So let's do a little exploring here while we're here. This nebula, to say it's interesting is an understatement. I'm gonna take this out of the way, and I'm going to remove the telescope stuff for now, so we can dig in and dive in here. Let's zoom in here. Okay, you'll notice in the center of this nebula that it looks like it's hollowed out, and indeed it is. It's hollowed out by these hot young stars in the cluster that formed here. I see you have to focus, by the way. This is a little bit soft. I'll take care of that next.
I was about to recommend that.
Yeah, I'm gonna. And then what happens is these stars are hot, and so they have radiation pressure that pushes out. And as that radiation pressure pushes out, it pushes away gas and dust from it. And there's plenty of dust in the universe, from previous supernovae and red giant stars making basically soot in their outer atmospheres of various kinds. And so what happens is when this happens, you'll find that young clusters will often make little cavities around their local formation zones. And then, because they're hot and copious stellar winds are coming from these, they carve other features in the gas and dust. For instance, let's go over here. All right. Let's go over here when we can get over there. I'm waiting for it to... there we go. So if you look right here, you'll see that there's like a... Let me zoom in on this some more. Okay. Right here, there's like a little stalk. You see that? In fact, I'm gonna go point that out to you. Right? So you'll see that there's a stalk, and for instance, right here, this is a little stalk right here. It's a stalk that sticks out. See it? Right there? Right there. That stalk is being carved by these stars because their light is coming down here, hitting the dust and pushing it away. But at the end here, there's a little dense area. There's a dense area of dust in here that is resistant to being carved away by this stellar winds from these stars. So it forms a little shield to everything behind it. And so what's automatically made is a stalk like this, okay? It makes a stalk. And we see these in many clusters in many locations. So our focus is a little off right now, and I'm going to do it. I'll take care of it in a minute. But this dark material here, again, is being carved by these stars. And these little dark areas right here are called Bok globules. Now, Bart J. Bok discovered them and discovered that there are stars and perhaps, as we know now, planetary systems forming within those. Now, I did an analysis of the Rosette Nebula, determined how many light years across these were, and figured out that these were more than big enough to house multiple star systems. It's quite impressive. So the temperature now out there is 13.25 Celsius in the building. So what I'm going to do is I am going to clear this stack without saving this right now. Right? And I'm going to bring it back. I'll bring this back. Right? And I'll bring back my telescope setup here. All right, and so what I'm going to do now is get out of the stacking and go into a mode where I can actually do a focus run. All right, so I'm going to just click this here to, first of all, let me do this. I'm going to get us to 1 second. I don't want to make you wait 20 seconds to see something. Okay, so there is our defocused stars. And what I'll do now is a focus run. And when the focus screen comes up, we'll be able to click on it. I'm waiting. It says, you see the time is frozen here, so sometimes we have to wait for a Starlink satellite. Okay. Yeah, and I shouldn't have clicked it again. Okay, here we go. All right, so what we're going to do now is we're going to tell it to commence focus run, and it's going to start selecting stars. Right now it has 9, now 14. That number will climb to a maximum as it finds what it needs. Okay, we're at 43 stars. We can zoom out and show you what it's actually seeing. So this is what it's doing. It's capturing all the stars in this zone, and it's focusing on those. It's actually building a parabolic curve, and that parabolic curve, the lowest point of the curve is the focused stars. So we're going to see a curve built over here, and we're going to end up seeing a low point in the curve. Right, you can see now that it's got this inflection point already, and it's going to come around and come up and put a line somewhere in here as it builds in more data. Ralph Wooden, yeah, photons, solar sails wouldn't work if a force wasn't being imparted to them. There's our best focus. This curve is pretty well intact, so I will now just say go to best focus, and this will come all the way over here, right, and come all the way back. You'll watch the stars at the end of that delay. You'll watch the stars just pop into perfect focus, and there they are. And so now we can just get rid of this. All right, so now if we were to take this image, we would see that the stars are in perfect focus. We'll do 1 or 2 20. I'll do 20 seconds because that's all we need. All right, and we'll go get the live stack, and you can compare, all right, what you saw last time with what you see now. Be much, much better. Very Lucia Campos, how are you? And we have Kyle Lynch with us. Lynn Beats, how's it going, man? Now this is, as Daryl said, it's the Rosette. Okay. And now we can see the details far nicer because we now have a very well focused image. So we can play with this like this. Now this is the first one. Okay, when the second one comes in, you notice how that gets like a little darker. What you're actually seeing is a reduction in noise. The more images we get, the less noise we get. So you just stack these images. That's the stack. So it aligns the previous image with the next one and lays it on top. Then it does the same thing all the way up and builds a stack of images. The more you do, the more you end up with a beautiful looking object. Let's see here. Anime Odin, Photon Sailor. Okay. Daryl, what was that thing that Amanda used to like? That had to do. It was an anime thing, wasn't it? Amanda Curran was our previous co-host.
Sailor Moon?
Sailor Moon, that's right. Yep. She likes Sailor Moon and dressed up as the character. Yeah, Ralph Wooden. Make sure you connect with me. Go to skytourlive.org. Send me a message, and we'll arrange to have you on with us. I'm sure there's lots of people that love to hear what you do as well. I gotta tell you, folks, we're about to drop some cash on equipment. We're getting 2 mounts. We're going to get one for this telescope and one for SkyTour Benson. They're going to be identical mounts, and I mentioned before they're the Skywatcher EQ6R Pro. What's it mean? It means that both are going to have a very, very rugged, robust mounts that are time tested. And sometimes you'll notice with this mount and this telescope, we actually have some mechanical issues that crop up. And it's almost always the mount. I'm going to get mounts that will not have mechanical issues and can withstand the heat and the cold. And it's going to be really, really nice. So, okay, so now in here, when we zoom in, you can actually see, even though we only have 9 frames here, we can zoom in and see the we can see the stalk now, very obviously. And the top of the stalk cannot be eroded. It's very, very dense. You see another one over here. There's several in here, and as we take more images, they all become clear, and they're all pointing at the stars because the stars are radially putting out their energy, and they are causing the erosion of the dust and gas in this nebula.
When you see those stalks, you alluded to this earlier, Mark. It's the very same thing that we see in the Pillars of Creation images, like M16 Eagle Nebula, for instance. They gave them the fancy name Pillars of Creation, but it's exactly the same process in both nebulas.
Yep. Daryl speaks the truth. Exactly so. And it's actually pretty interesting. All right, so we've taken 13 shots here. You can see now with real clarity, you can see this stalk here that we've been talking about. A lot of the noise will be removed, but there's the stalk. Okay. And you can thank these stars for eroding away this dust and gas around it to expose it, just by default. This is the dense part right here. And this is the part on the lee side and the protected spot behind it, away from the star's energy. So there we go. All right, so there's 15 exposures here. This nebula, the colors are red, and there's more red here than is actually showing If we want to actually do this a little bit more accurately, we'll do it like this. This is a little bit more of what it looks like. Whoops, not like that. Okay, kind of like this. Let me bring it back. Okay, and what's happening is inside this nebula, and I'll zoom out to show you the whole thing. Okay, and I'll process it to kind of bring back some of the other detail. Okay, and there you can see the cavity very clearly. This red is ionized hydrogen gas, and it glows red. That's how it glows. And then there's some areas in here, and actually this is where there's oxygen in here, elemental atomic oxygen. And when it gets ionized, it gets doubly ionized. 2 electrons leave the atom temporarily when they get this energy influx, which drives them off the atom. And when they rejoin the atom, they give off light, and that light tends to be greenish blue. And that's what we see here. We're seeing some of the oxygen, and we're seeing a lot of the hydrogen. The dark stuff is just dust. What is that dust? It's made of carbon and silicon, and the carbon and silicon dust particles are most times coated with ices, formaldehyde, methane ice, ammonia ice, carbon dioxide, and water ices, and more. And so when the stars are formed, what they do is they'll drive off that ice on these particles and form this incredible slurry of basically fundamental building blocks of life. So if we come in a little closer on this guy, I want to show you if we can get here in time. Waiting for it to come in here. Okay, here are those Bach globules I was telling you about right there, and we've got enough. We got enough of these to show these nicely. Look at the detail in there. These objects, each of these. Okay, when I did my analysis, I think this one was like 13 solar systems in diameter, and this one was a lot more. And so there's a lot of material in here, and the stars probably eroded some of the other stuff away and other gas away from it, pushing it away. But these two objects were dense enough to withstand that stellar light barraging this location. And so they're fine, and they last, and they survive. Now, the other thing that's interesting is, within these, okay, the copious, and I do mean copious, ultraviolet radiation from these stars, it can't get in, because this dark dust, when it gets dense enough, it actually protects. It becomes a cocoon that protects the interior from ultraviolet energy. And so, whereas we might say, well, in a nebula like this, it's hot, and it is, okay, but in these protected areas of density in here, the temperature inside these objects is a lot cooler than the surrounding area. So, in all likelihood, this object in here is actually somewhat fertile to produce a star with planets, and that the planets could end up literally becoming capable of sustaining life within this dark nebula here. Now, there's also thoughts that we're within one too. In fact, yeah.
I'm sorry, I hate to keep interrupting you.
Yeah,
Izabela has a good question.
Okay, I'll get to that in a sec. So, bottom line is that in these dark areas, like when we look at the Pleiades, we see dark nebula around the Pleiades, but the stars illuminate it and we see it. Okay? Well, it's possible that that dark cloud that the Pleiades is enveloped with, only 400 light years away from us, is actually also one that we are also within. So we can't see it because we can't really tell. So there, enough of that soapbox. What was Isabel's question?
Are we seeing to the other side through the cavity to the stars behind the Rosette, or it's a cavity in a giant cloud like a cave? I know it's a cave.
Yeah, I think that that every star we see in here is at some level of depth into this nebula. This nebula is huge. And when we look at the size of it across, if we think of it as roughly spherical, there's a lot of depth in here. So most likely, any stars on the other side are going to be very, very red because they're going to be peeking through dust and stuff inside here. So I'm not exactly sure if there's been any studies to show the depth of the Rosette Nebula. But the stars are moving. As the stars are made, they're also moving around each other. They're also moving around the galaxy, and so they drift. The cavity, if you center it, is about here. But wait, the stars look like they're focused kind of down here more. What's going on? Well, since it was formed, okay, the stars themselves have been moving. And even though this is a fairly young nebula, there is motion that occurs over millions of years, and we see that here.
That reminds me, may I expand on something a little bit? It's a question Michael asked earlier.
Sure,
Michael,
I'll go ahead and save this now, but go ahead.
Michael, there was no explosion that I know of, or at least I think in the sense that you mean it. An explosion did not form that hole, that cavity. It's just a process over millions of years that the first stars were born inside that cloud, and their radiation pressure started pushing the dust away from the cluster, started opening up that hole, that cave.
Yeah, that's right.
So not an explosion so much, just an ongoing process. It's like they're blowing open the blowing's even a bad choice of words. They're enlarging
pressure.
The size of the cavity.
Yeah, and you can see that the cavity's not perfectly round because the stars are moving and still radiating. So it's kind of clearing as it goes, right? And so you can see that it's sort of kind of down here a little bit and clearing. So you can see the stars have drifted and are doing more work. Who knows where they'll be in another 10 million years, But this nebula is going to be altogether different in 10 million years. All right, let's just save this here again. All right, so we save our
That's
raw
sort of
file.
begging the question, though. What class stars are those? I don't offhand see signs of supernovas, but are those stars capable of supernovas?
It depends. We'd have to look those up, see what the masses are. Many of these stars, you can have stars that are a few times the mass of the sun, and they're just going to make white dwarfs, And whether they make white dwarfs that are carbon and oxygen, or whether they make a magnesium neon dwarf, it depends on their mass. But this is really pretty. Look at that. Holy cow. I just realized what a pretty little image that makes. Isn't that something? Let's see if we can just process that a little bit. I already saved it, so we're good. So we pull this in here. Oh, look at that. All right, let's back out now, because I hear someone in the chat saying, back out, I want to see it. So I'll pull this back just a little. Look at that. Now, when I save it, it saves the entire image. It doesn't save just that little zoom that we did, so we're good. All right, so that's cool. So we'll get out of this now. We saved it. It'll be up on our site. And so we're going to go to another object here, which is really pretty. And let's do that. First of all, let me bring us back in here. We'll go to our driver here. And so by checking out these objects here, what we're doing is we're allowing for the galaxies that we want to look at to come up a little bit higher right now. And I know we have some over here, but let's go see if we can find NGC 4565.
I think I have an answer to my question.
Which is?
There are at least 2 O-type stars in the cluster,
Okay.
but I assume, they're not old enough to have exploded yet, obviously.
Yeah, but they're only going to live about 10 to 12 million years.
Right.
O-type stars are very, very hot and blue, which makes sense because they tend to be able to scour the inside of a nebula. All right, let's see here. Let's look at our altitude here. That's the most important number for us tonight.
Those 2 O-type stars are primarily responsible for blowing the bubble in the cloud.
Mm-hmm.
Anyway, sorry.
No, it's fine. Okay, this is NGC 4565. We're gonna go there and see what we get. It should be within our view. So off we go. There goes a Starlink satellite. And there goes our telescope.
And Rosette, the star cluster is 2244. If I said 2144.
No, you said 2244, I thought.
Oh, did I?
I thought so. Okay. Another Starlink satellite. Well, let's move up a little bit because I think what we want to see is right there. Maybe. That looks it.
Boy, you'd think if the Starlinks were flying through your field of view, you'd have pretty good coverage.
I do, though, as you notice. I mean, we're not having any problems right now.
I see a needle.
I do too, and that's exactly where we're going. All right. This galaxy is spectacular, guys, as you'll see.
One of my favorites.
Yeah. Okay. Move over a little more. I gotta tell you guys, I don't know what it is, but I've just not gotten over the fact that this telescope is 2,500 miles away from me right now, and I'm making it do our bidding. And the Benson scope's going to be as far away, and so that's going to be pretty cool too. It should be pretty close. Let's do this.
This is Jetsons kind of stuff when you think about it.
It is. Yeah, it really is. Okay, so there we go. So that's pretty good. All right, so that is where I want to be, and I'm going to turn off our reticle now. As cool as it looks. And come in here, and I'm going to resynchronize. See, there's where the telescope thinks it is, and this is where it should be. So I'm now going to synchronize, and you'll watch this come over and land on top of that. So now we are perfectly synchronized. So now what I'll do is I will kind of zoom in a little bit. Looks really good. Let's do a 25-second shot. Okay. There we go. Watch our yellow box. That's our progress bar down here. Okay, when that fills up, we're ready to go. So I'm going to get us out of this mode. This is our, it's basically a little histogram to kind of give us a nice view. This is our previous guy. And we'll clear it because it's been saved. It's up on the server probably by now. Lewis TA, what's up, man? Lewis is with us. Lewis is in the house. And let's see. Ah, there it is. Look at that. What a beautiful galaxy.
One of the first galaxies I ever saw.
Wow.
Still one of my favorites. You can see why they call it the Needle Galaxy.
Yeah. And look, we got
You're
more
seeing a
galaxy
spiral
here.
galaxy, but you're seeing it edge on.
Yep. So you're seeing that dark line of dust. And that dark line of dust, like our galaxy, like the Andromeda Galaxy, comes from countless supernovae over the billions of years of the existence. And it also comes from the countless supergiant stars that made the dust, and it was liberated in the supernovae. See, red supergiants get so big that if you put, say, Betelgeuse, for instance, the upper left star in Orion, if you put that star in where the sun is, then Betelgeuse would go out all the way to the orbit of Jupiter, right? And that's a radius. Never mind the diameter. Diameter is a full size on the other side. That's a lot of material. I mean, nearly a whole solar system full of material inside of a star. That's crazy amount. And that crazy amount is actually something that is going to end up being liberated back to the universe as soon as the star goes supernova. Betelgeuse may have gone supernova already. We don't know. It's about 700 or so light years away from us. And it's going to definitely be visible from here. In fact, it'll be visible in our daytime sky when it finally does go. You know? And that's what's incredible about it. Let me pull out a little more detail here by adding contrast. Look at that. Isn't that beautiful? We're at 5 images stacked, if you notice right there. Okay, it says 5 images stacked right here. And none have been rejected. So that's good. So we're going to get a good set of exposures here in our stack. And we can actually probably zoom in a little bit and check things out. Okay.
Ruh-roh.
No, we're good. It's going to
I see the scope is looking right over the roof on the east side of the observatory.
yeah, it's not doing anything bad. It's actually pretty good.
Yeah,
Okay.
pretty far to the east, though.
Yep. Okay, one moment, guys. We're gonna bring that screen back here. There we go. And let me take care of a little housekeeping here. And there we go. Okay. That's an artifact of the zoom. It's not really there. It'll actually alleviate. Look at that. See the detail in this beautiful band here. A lot of detail in there. Let me try under enhancement. Let's try taking off the sharpening to see if we can see more detail by softening a little bit. Okay, let's put that back on. And let's go back to what's called our histogram. And let's play with the data. One of the things we can do is by moving this over, okay, take the white level, right? The mid level, and we can take that level and move it down a little bit. And if we move it down a little bit, it's going to soften things up in the background. It's going to give us less noise to deal with. Okay, and then we can come back here. And we don't usually want to take our curve beyond the peak, because then we're going to start losing data. But if we want to focus on looking at the dark central area, then we can go by this just like this a little bit, because this is bright enough. This is the nucleus of the galaxy in here, and it's showing out from just underneath. What that means is it's not perfectly edge on. It's a little bit on an angle up to us, so we're kind of peeking underneath the disk of this galaxy from here. Okay.
Well,
so let's pull out now. Let's get our processing back out, and let's do this. And let's back out of this. Let's pull this value more toward the peak again to darken our background. 14 exposures so far. It doesn't look bad at all. Looks pretty good. Alright, so who in chat is going to be on the line of totality? And hi, Carl Becker, I see you're here. Thank you for coming. Yeah.
Louis Ta asked a question.
What's he say?
If Betelgeuse goes boom, would it be a black hole or a neutron star? I said, I didn't know. It could be either. Then Izabela chimed in. Seriously, Betelgeuse can become a black hole? If you aren't kidding, then we should be more concerned not about the explosion, but about the black hole after that.
The black hole's not going to bother us.
No, it won't bother us any more than the star does now. 600 or 700 light years away is too far to have any effect on us.
Yeah, that's true.
Bullwinkle's here.
Hey, Bullwinkle, what's up? And Renee is here. Hi, Renee Behrens. How are you? Renee Behrens is Alicia Vieira's mother.
Oh.
Yep.
Is Darlene there tonight?
Oh, that's a good question. I would think she's probably in bed by now, because they're an hour off of us, so it's going to be almost 11 o'clock for them. Okay, I want to address that black hole versus a neutron star thing. Okay, first of all, when a star goes supernova, a lot of its mass is expelled. Whatever's left behind, if it's beyond a certain mass, then the star could continue to collapse past the neutron star state and become a black hole. So whatever's left behind has to be, I think it's like 2.7 solar masses or more to further collapse into a black hole. Under that, then it'll go to a neutron star. So there's like a narrow range where things become neutron stars, a narrow range where they become black holes and beyond, a narrow range where they become white dwarfs, a narrow range where they become a certain type of white dwarf, a white dwarf that's a magnesium neon oxygen white dwarf versus a carbon oxygen white dwarf. So Ralph Wood makes a comment about the inverse square law. Let me explain that. The way light operates, it becomes diminished in intensity by the square of the distance away. So if you shine a flashlight, right, and you go twice as far away from the flashlight as you are at the origin, the light of the flashlight becomes 4 times less intense. And same with stars. The farther away from stars you go, the more diminished their light becomes by that square. So if you think about it, we see things like fast radio bursts, which are, again, those are light emissions, just light we can't typically see because they're in the radio spectrum, which is long wavelength light, okay, way beyond anything we can see, but we can detect it with our radio telescopes. And some of these fast radio bursts are extremely powerful, and they come from billions of light years away. Imagine the strength they must have had when they originated in their originating galaxy. Absolutely incredible. So 22 images here. We'll go a couple more. Okay. Waiting for our Starlinks to come back. Let me pull these back. Okay. And do some housekeeping. Housekeeping. There's the housekeeping. All right. Hey, old school. How you doing, man? Good to see you. Thanks for coming out. All right, so folks, keep in mind, tomorrow I probably I'm going to do, maybe during the day or afternoon, I'm going to do that live stream for the solar eclipse. I'm going to talk to you about the solar eclipse and do my presentation, my talk that I was hired to do for this organization, okay? And like I said, it was a full house. People really liked it. So I can do it for you, and I'm willing to do that, and they said it's okay if I do that. Go ahead, Daryl. I cut you off, I think. Daryl, I cut you off, I think.
No worries.
Okay. This is good. Let me change the name here to NGC 4565. And it's a Galaxy, GAL. Neat. Save it. Save exactly as seen. Here it is. So what do you see? Okay, here's the image that you're going to get. That's the image right there that shows up on the server that you can take down. You'll be able to zoom in on it. You'll be able to look at it up close, check it out, see the detail. It's all available to you, and that's free. We don't charge you at all to see our results. All right, so that's now heading up to the server, and we'll be up there in just a few seconds. Excellent. So now that we know it's there, I can clear this, end the stack, and get into the hunting mode for the next object. How would you like to see, Daryl? You got any ideas?
I'm sorry, say again.
Do you have any ideas for what you'd like to see?
You're close to Leo.
I am. Yep. Definitely close to Leo, and
I don't know. What else is in Coma Berenices? You're still kind of low.
yeah, that's for sure. Let me go see. Let's go see. Let's go see.
There are any... let's see.
Yeah, there's a lot of galaxies in here.
Yep.
Oh, we got the koi fish right next to us. And then up here, We have some more NGCs. I have a cluster of NGCs in the Coma cluster.
You have
We have another one up here.
you have a bunch of M objects in Coma.
Yeah.
M100, M99, M98, M91, M88, M85, M64. People always get a kick out
Oh
of
yeah,
that.
M64. You're right. Let's check that out. All right, guys, this is another one you'll like.
If it's not behind the building still.
Yeah, let's find out. M64, right?
Yeah.
I can get its elevation. If it's above 45, will be good. The black eye. Elevation, altitude is 35. Might be close. Might be close, but we can maybe try it. All right, let's find out. Let's go see. Let's go see. We'll see part of it, I think, but it's going to be a little bit behind. There it is.
All right.
Yep. We might just make it.
Looks like you might just be clipping the edge of the roof.
Maybe. You're right. Maybe we are. Okay. So, what are these fuzzy spots we see? Well, these are galaxies, certainly, that are really worth looking at. When you see this one, it's going to be really worth looking at. Now, on the end of the telescope, there's a camera, and that camera has a little tiny red light on it. It's facing outward. That camera is normally in the back of the telescope, but with this particular setup, it's on the front. That actually works for us because we're trying to figure out, we're looking to see if we can see objects over the roof of the building, and if they're not going to be visible, then we want to have a way of knowing that. And the way we actually know that is because we'll see a red haze in our image, and it's that tiny little LED light, which is really, really not very bright at all. But with the sensitivity of this camera, it really shows. So if we see red along the bottom, okay, or along this side, we'll know. So here, let's go check this out. We're going to set up an exposure, and we're going to do 20 seconds on this. All right, and off we go. And we'll stack it. All right, let's go wait and see now. Did we get our first one? Yes, we did. Okay, and we're going to get rid of this. And that'll make it look way better. And then we're going to color correct. Actually, we've never seen the black eye with this camera.
I thought we looked at it a few weeks ago.
No. Wasn't high enough to see. I don't believe we did. Wow. See, this camera we're using is literally fine-tuned for the telescope focal length that we're using. So we're getting exceptional images from this particular camera. It's the best they could be for this combination. That's really pretty. That's the Black Eye Galaxy, so named because it looks like it got a black eye. we might be able to actually enhance that a little. Let me see if we can enhance this. Okay, that did. I can kind of see a little more detail in there. We'll let this go for a little while, and you'll actually end up seeing much more detail in here. What was E-Man saying?
I don't know.
Okay.
I thought he was talking at me.
Oh,
Evidently
Daryl.
not.
Like saying your name, and you forgot the D.
Kind of what I thought.
He's writing, who is at Errol? Well, this is like you said, this is the Black Eye Galaxy. It's a really pretty galaxy.
I always think of this one as the I'd rather fight than switch
Right.
galaxy.
Yeah. Yeah. Okay, let's bring this up to just near the top of the peak to kind of get the maximum value of darkness out of this. We're going to pull this down a little bit. This is our mid-level. There we go. Now you can start to see the circularity in here. You can see some of this circular detail in there. See that? Trisha Ferreira, how are you? Trisha's with us. We can all breathe a sigh of relief. Trisha's with us. Nice to see you, Trisha. Go ahead.
Some think Messier 64 here, the black eye, is formed from two galaxies colliding. You see some professional images of M64, and the dark black eye patch there is tremendous. It has a lot of stars coming to life inside it. And if I'm not thinking of the wrong galaxy, I think the core is actually rotating the opposite direction of the rest of the galaxy too.
Well, that's worth a look up.
Let me give that a look.
You'll also notice something else, guys, and that is when there's a lot of data, that part of the image really becomes very well, I should say, noise-free. And the rest will catch up. This stuff averages out over time. All right, we've got 14 images of the black eye here. And this is only 20 seconds, so that's not bad, huh? You'll notice our stars are nice and round. This full width half maximum filter, it decides, okay, we can actually go smaller. It decides by setting this value, it decides what size the stellar images can be, and it will reject those that are bigger than that. So depending on where we're looking in the sky, we have to make adjustments. And so right now I have it set to 7.81, and so far we've had no rejections. All the numbers are under 7.81. E-Man, no one's trolling you here. We don't do that. Wow, this is nice. I'm going to try and add another enhancement. go way up. Maybe it was too much. Drop it back a bit. Nice.
And yes, the inner and outer portions of the galaxy are rotating in opposite directions.
That's a strong indicator that there has been a collision.
Yeah.
E-Man, I don't know who you're saying that there are impersonators in the chat. Everybody in the chat are people that I know about so far. There's a few new faces, which is great. By the way, for any of the new faces, subscribe, man. Subscribe. Hang out with us, You can, if you're interested in stuff like these photos, you can go to our Etsy store up there in the upper right corner. It's called SkyTour Shop. And we put a lot of our pictures on all kinds of things. Mouse pads, lamps, blankets, sneakers, bathing suits, mugs and cups and tumblers and travel mugs. We put these pictures, and a lot of people have bought our stuff and they love them. And some of the people that bought them are probably here in the chat as well. Hey, Water Rat 1344, how you doing, man? Thank you for coming out and checking us out tonight. So do make sure you subscribe, guys. Oh, and thank you, Mr. Django, for reminding me. We just had our batch of T-shirts made. You have a SkyTour live.org button, not button, but a decal on the front. Not a decal even. It's everything's paint. We don't do the cheap stuff. And on the back it says the universe live in real time with a nice design. And those are going to be available where we are when we're live. So we'll hopefully have some. We will have some out in Indian Wells or Palm Springs for Contact in the Desert. I won't have any in time to ship to me anyway, to have for the Ozark conference this weekend coming up. Izabela, thank you for putting up that link to the store. Okay, now you can see more detail resolving itself in here. This is what happens when you allow the noise to be subdued by stacking image on top of image. All the subtle detail is pushed to the top and made more obvious. Okay, so we got 27. We have Black Knight Galaxy M64. We're going to save it.
Carl Becker asks an interesting question. He's directing it at you.
Okay. All right, we're done with the black eye, so we'll go to our finder mode here and bring it up. Okay. Where's Carl Becker's question? Oh. Are there any new things being found in the night sky? Oh, that's an excellent question to ask Izabela in the chat. Because what Izabela's done, Carl, is she has taken our data that she's looked at, that we've took for like the last year and a half, 2 years, and she's combing through a lot of the images of the same object, just to do comparisons, and then comparing them to see if things have changed. And guess what? She's found change. So you can do real science with our data. And Izabela discovered, for instance, stars that have vanished. She's discovered asteroids that were going through the field that were unknown. Not the asteroid was unknown, the asteroid was known, but we identified that it was passing through the field. She did, actually. So it's actually really cool So there are unknown things that are still being discovered, yes. The James Webb Space Telescope, when you have that kind of power, well, you certainly do get to see lots and lots of really cool stuff. All right, so let's go.
There are still Earthbound astronomers finding new things in the sky, too.
That's right.
That Bray Falls guy,
Mm-hmm.
he's the guy that's big on finding extended oxygen-3 objects out in space. And
Yep.
there are other people that they're still finding little miscellaneous nebulas and stuff like that out there. Big stuff's been seen, but there's still a lot of small stuff to find.
Yeah, that's right. Okay, well, let's do this. Let's
You want another?
Yeah, go ahead. What do you got?
Let me see if I still have it. Where'd it go? There's M100, M99, I believe.
Oh, right. That's right. M100. Is M100 a pinwheel? Yeah. It's the blow dryer galaxy. What's the... Let me look at the altitude on that. Oh, 51. Ooh. Well, we got the Virgo cluster of galaxies, which is all these little red dots, is here, and the Silver Streak Galaxy is there too. You know?
The SA100's in Virgo?
Blow dryer galaxy. Am I not in Virgo right now? Markarian's chain is here. Excuse me.
Oh, well, it's in Coma Berenices. It's part of the Virgo cluster, though.
We're just across the border. See the border? I think that puts us into Coma. All right, hold on. All right.
Is that up high enough yet?
I think we're at 51 degrees on this one. I'm looking now. We need 40 plus. 52. Yeah, we got plenty. All right, let's do it. Excuse me.
It's a grand design spiral.
Yeah.
Brightest and largest galaxies in the Virgo cluster.
Mm-hmm. Okay. So we're higher now than we were before, so this is good. And that's it right there, I believe.
Yeah, Messier 99 is interesting too. It's in Coma.
Okay. Okay, so let's...
Gotta catch them all, as they say.
I know. All right, let's... It's right here. I'm going to center it up here. north jog here. This is good. Okay. Now we'll let it. It's going to do searching now. It's going to look for our guide stars. After it finds our guide stars, it will begin to guide. Meanwhile, I will set up our exposure.
Mark, excuse me a moment, please.
Of course.
Be right back.
Okay, let's set the exposure to 25 seconds. We are guiding. And let's start shooting. All right. And we'll get rid of this. Okay. And this is Messier 100. A galaxy. Okay, the first one was just out of our range, so we're going to raise that bar here a little. Make sure that our exposures can do the limbo underneath that bar. Right there. Let's see what we get now. Not quite. A little more. Just got to tune it. Let's see what this one does. This one should fall in. Alright, we got one. Look at that, guys. Very nice. Let's color correct. Get all our curves lined up with each other. And then let's do a quick process. This is going to be a little too much. We're going to pull this over here to just to the left of the curve, which is what we normally do. And this guy goes an equal amount out. We'll back out a little just to allow detail to come in, but allows us to see it from a distance. See the spiral arms in this galaxy. What's interesting about galaxies is that the spiral arms, the way they form, we think we know, but there's actually a number of theories. One of them is that these spiral arms in some of these galaxies form through interactions with other galaxies. The Whirlpool galaxy, Messier 51, is an example of that. The disruption to the galaxy caused by that satellite galaxy that passed through it and drags some of the material downward with it, away from us, basically, may have induced the formation of the spiral arms in Messier 51. This galaxy, on the other hand, may or may not have interacted with this galaxy. Probably not. This galaxy, probably not. You have this one, this one, this one. You see all the galaxies in here? Okay. Lots of galaxies in here. Okay. But it doesn't mean that that's how these arms may have formed, because there's another methodology by which these arms can form. And that methodology is something called density wave theory. Now, density wave, okay, if you think of these arms of the galaxies, they're dense areas, right? But now for the part that you just aren't going to find that makes sense, and that is that when you have stars forming in the galaxy, they orbit the galaxy. And they tend to orbit the galaxy faster than the spiral arms do. So what's that mean? It means that the stars move into and out of the spiral arms. But then, what are the spiral arms? The spiral arms are the collections of dust and denser gas in the galaxy, and they have their own mutual gravitational attraction that pulls things toward them, All right, and what is the density wave mean? What does those words mean? Well, if you look at this spiral here, and you look at this concentration of material in here, think of that as a cosmic traffic jam. When you have a helicopter flying over a traffic jam, it's like, well, the highway is pretty, so we've got all kinds of traffic on the highway there. We're going to have to get back to you with traffic and find out what happened to this traffic jam. Well, what happens is cars move into a traffic jam, slow down for a little while, then move out of the traffic jam. But the traffic jam's still there. If you paint the top of a car red and you videotape it entering a traffic jam, it'll slow down, crawl along for a while, then speed up and leave. But the traffic jam is still there. New cars come in, get bound up for a while, and then those move out. But the traffic jam persists. That traffic jam is the spiral arm in this analogy. And that's how spiral arms in galaxies appear, anyway, to work and appear to be formed through these traffic jams of dense material that slows down things entering it and then accelerates them back out on the way out, you know. So that's somewhat of the nature of that. Mark, are we talking about summer? This is Curtis. Talking about summer plans tomorrow. I'll see if I can make it. It'd be interesting to have a panel discussion on alternative propulsion. Yeah, I don't know if Contact's gonna do that. If they did, I think they're gonna throw me on that panel. I am on a couple panels, or at least one panel, I think, with Contact in the desert. But so that density wave theory, then that's how spiral arms are thought to persist and propagate through the galaxy. And the fact that they kind of flow back from here and kind of drag behind, this is due to differential rotation. The stuff in the middle is going around slightly faster than the outer stuff. But the weird thing was, we found that the galaxy rotation curve doesn't operate like we would expect it to. We look at Mercury; it goes around the sun once in 88 days. Pluto takes 270 years to go around the sun. Maybe I forget the exact number. So the farther away you are from the gravitational concentration, the nucleus, like in a galaxy, the slower your orbit would typically be. But in the case of a galaxy, we would have expected these spiral arms to wind up a long time ago, drag out multiple times, but they don't. So there is a process that prevents the spiral arms from winding up. So what is that process? That process is related to another potential mass that's in a galaxy that we don't know about, something called dark matter. Now, there's many experiments that are being undertaken to look for dark matter, including some interesting particle accelerator experiments that are currently being worked on to do hunt for dark matter. Because if dark matter exists, we're going to find it in these galaxies, because the dark matter is sort of pulling this other sets of spiral arms along with it, preventing them from winding up, if that's actually how it works. Dark matter may not exist, nor dark energy, because we have not found dark matter yet, or dark energy. We just see the results. Dark energy and dark matter are two different things. Okay, but let's stick with dark matter for the moment. Dark matter has not been discovered. It's something called non-baryonic matter, not made of the typical protons and electrons and so-ons that we know about in our classic model of physics. So, if that's the case, then it means that it's possible that there's some other kind of exotic matter that's out there that we don't know about yet. Hence, the hunt for dark matter with some of these, thrusts and programs that are being undertaken right now.
How can they say, you know how I feel about dark matter, dark energy, but they say Messier 33 galaxy has no dark matter in it.
Well,
how do they rationalize that?
I don't know, actually, because Messier 33, based on its age and existence, maybe it's not wound up, or maybe there's other processes that keep it from winding up. Maybe interaction with the Andromeda Galaxy has been taken into account for it. That's a possibility, too. At least all of this stuff is theoretical. It's the cosmological things that cosmologists love to go after, and that the astrophysicists say, is that true? Let me figure out if there's a way that I can, rationalize this. So I don't know, but Messier 33 in this telescope is this big, and that's because it's this big. That's because it's 2.7 million light years away or so. This galaxy, on the other hand, is a lot further. We're looking at Messier 100 here, and we're the blow dryer galaxy, as it's called, and its distance is 55 million light years away. So that's pretty far. But as Daryl said before, it's a grand design spiral. It's a face-on spiral. You can see those spiral arms beautifully. However, you'll notice that there's some rather sharp angles in these, which indicates that it may have interacted with something else in its distant past. Because when you look in this frame, if we zoom out a little more, all right, and look in this frame, you'll see that there are a number of other galaxies in here. Okay? I mean, quite a number of other galaxies. Right? You'll notice, well, that's kind of small, isn't it? It went too far. But you'll see that we have this one. Okay, we have this one, this one, this one. I mean, there's just a quite a large number of galaxies here. Right, besides that, we've got this one, we've got this one, this one. I mean, we could spend quite a while doing this. We have this one, all right, this one, and there's one right here. So we're in a cluster of galaxies right now, okay, and there's one right here I missed right there. There's a little one right here. And it just goes on. I think there's one right there. And there's more, and many, many more. So this is, again, this is, any one of these galaxies may have interacted with this at one point or another. Okay, like this galaxy right here. Let's go find out what that galaxy is. Let's do this. Let's center on this. Okay, we're centered. And we'll go zoom in now. Okay, and the galaxy we're looking at down below is this one. Okay, back out. Come on, come on, come on. Okay, stop. Okay. It's NGC 4312, which is this one down here. And let's see its distance. It's going to be further away, I think. This is 55 million light years away. This one is, well, it lists closer. It lists at 38 million light years away.
What about the one just to the left in your image, which is
Right there.
to the lower left in the stellarium image?
This one.
Yes.
Now let's see what that one is. That one shows as 77 million light years. So,
So
theoretically possible. It's theoretically possible that that one is one, or this one that was interacting. Let's find out what that one is up top.
Actually,
That's this guy.
I could see a faint extension of another arm on the left-hand arm in your image, and I think they show in the stellarium also.
Okay. This one doesn't have a distance. But let's see the faint extension that you're talking about. Are you talking this side or are you talking this side?
The left side,
Here?
yes, that right there.
Yeah, I see that. Let's see.
I would guess that's the same thing that made that big egg-shaped lump in the inner spiral arm there on the left side,
Yeah,
the sharp corner you talked about earlier.
yeah. Let's see if we can pull that out a little bit. We're going to do a push. This is called a push. We're going to bring those curves closer together and try to push some data out of this and see if we can grab some extra detail. It becomes a little more grainy, but it might allow us to see that hidden detail. Yeah, this galaxy has had this spiral arm pushed away in a sense, and this one has been collapsed. So it interacted with something. There's another galaxy right here. I'm not sure, Daryl. But this is pretty good right here. This view. Okay, I'm going to save this galaxy like this. We've got 35 images here. And then we'll save it exactly as seen. Curtis, yes, we are in the Virgo cluster region. So let's come back to our planetarium shot here. There's so many things to see here. It's crazy.
See how close Messier 99 is to Messier 100,
Okay.
because it's also in coma. Curtis, we're in the Virgo cluster. We're still in the constellation Coma Berenices, though.
I just answered that for him. Okay, let's see where M99 is. Maybe this. The Virgo cluster pinwheel. All right. Its altitude and azimuth, its altitude's 56, so it's right nearby. So why don't we clear this? I'll save it one more time because we got a couple more shots. All right, and then we'll save it exactly as seen. Now we'll clear it because that's going to go up to the... It's got some beauty in it too. That's probably going to produce a lot of nice data. And we're going to go to 1 second here. Okay.
Michael, a short answer to your question: is there a pattern to solar eclipse locations on Earth? And I commented in chat, they do run in cycles. they call some of them as Saros. I'm no expert on this, but I know I went down to El Paso, Texas, in 1994, I guess it was, to see the annular eclipse down there, and there had been a couple of eclipses in the meantime that have sort of repeated the motions of that eclipse in the 90s, but each one has happened a little farther north. And I remember reading that they are related. They're part of the same cycle of eclipses. And there are different cycles and different series and all sorts of stuff.
All right, let's move over.
This is a nice galaxy. It's a little smaller, though.
Yeah. Okay. All right, we're gonna wait. We're searching right now. You can see right there. As we're searching, and we're gonna get numbers. Here we are. So we're gonna come in here and do another 25-second exposure here.
This is another Grand Design spiral.
Okay.
And it's actually a little closer than M100 was, 49 million light years.
It's a little smaller though.
Yes. And this one, if we talk about gravitational interactions, it's got one great big spiral arm and another one that looks like it's been kind of pulled apart into several sub-arms, you might say.
All right. Okay. All right, let's go into our stack then and check it out. We'll get rid of our histogram over here, which brightens things up. Does some processing.
Marianne is here.
Hey, Marianne, Rob. Yeah, you are really late. What are you doing? Show that girl some love. She spends so many hours helping to keep this observatory up and running. She runs out to the desert on a moment's notice when needed. She's just crazy. Oh, look at that. Yeah, that's going to be really pretty.
The one, you can see the difference there. The lower arm hooking up to the right, that's the big spiral arm, and then something disturbed the other spiral arm.
Mm-hmm.
More toward the top left.
Yeah, you see that.
See how this might clear up when you stack a few.
Yeah, we've got 2 so far. Let's just color correct first, which we're very close already. And then if we process, it's going to soften it up a little bit, but it kind of actually helps with the noise. Okay, so that's great. Look at that. We'll move this over just to the left of the peak. So this galaxy is 44 million light years away?
I saw two different numbers in the same article.
Okay.
One says 49, one says 45 million light years.
It only makes a difference if you're traveling there in a spacecraft.
Yeah.
Cool. All right, 5 good exposures right here so far. By the way, you guys, I know that this is where the data is, but I have a curved screen. I say this often, so on the left side is the live observatory feed, and on the right side, that's the broadcast feed. So it's a big curved screen, so I'll be looking to the left and then shifting over to the right, back and forth. I don't mean to be looking away from the action here, right? But I see the action before you see the action. Because the left side of the screen is the immediate observatory feed. Okay, let's zoom in on this a little bit. Because we can. Wow, look at that. That's actually got quite a lot of convolution in here. There's a lot of dust in this galaxy.
Mm-hmm.
Let's bring the peak in to the top now, just a little more. Wow, look at that. That's really pretty. All right. That's a really pretty galaxy.
It is.
All right, we're going to let that come in. We're going to come in here, pull out of this area a little bit. And we might go to Silver Streak after this. Silver Streak is actually quite an interesting galaxy. Look at that.
Sort of like if we saw
Not quite edgy.
4565 with a little more tilt on it.
Yeah, that's right. Exactly right. And Silver Streak's a little bit bigger than this galaxy too. Let's go back and see actually. It's 6 minutes by 1 minute thick.
Presently looking at Messier 99, Izabela.
Very good. Okay, so yeah, this is 99. 99? Max? Who gets the reference?
Good, smart.
I'll try my best. Yeah. This spiral arm almost looks out of place, doesn't it? Because it seems like it's being spread away from the galaxy by something. These look tighter, and then you got this one loose guy just hanging out there. It's like, hey, wait for me.
The article says that the arm to the upper left is the one being disturbed.
It looks it, yeah.
It,
You can see right here.
Evidently, there's still an interaction going on at this time.
Mm-hmm.
They said when it quiets down in the future, it'll probably go back to looking like the other arm again.
Mm-hmm. M99. Galaxy. Okay. 15 images. We'll do a preliminary save right now. Old school. Missed it by that much. I'm glad you're loving it, old school. Let's go see what our night sky looks like here. If we bring up our all sky cam here.
Who's the actress that played Agent 99?
Oh, that was Barbara Feldman and well, what's his name? Don Adams.
Yeah.
Actually, let's go back to live view. There we go. And if we look here, you can see the Virgo cluster region is just replete with all kinds of amazing objects in it. Yep. These are the lights of Phoenix, 80 miles away. And we had clouds come through last night. And as the clouds come through, they come through here. They're dark. All right. And they get light when they head over toward Phoenix, which is kind of interesting. We're right around here right now. That's where we're looking. Right in this region. Okay. So if we zoom in on that, this is where we're looking. Which, let's see, right about here. All right, so there you go.
There's Leo.
Yeah.
Virgo's to the left, lower left.
Yeah. Here's the reverse question mark. There's Regulus. The
There's
back
his
triangle.
tail, Izabela.
Right there, yep.
Virgo to the lower left.
Yep.
Well, in this orientation, more to the left. Coma's up between and above the both of them.
Yeah, and that shows us this faint cluster right here.
Yep, that's Bernice's hair right there.
Yep. Here's the Big Dipper, guys. There's the bowl of the Big Dipper. These three stars point to the bird turret. Well, actually, they point to Arcturus.
And that's Spica. You speed on Arcturus, or speed on to Spica. Bright star at the bottom left of the screen.
Where, here?
Yes.
Oh, that's true. There it is.
Yep. That's Virgo's left hip. She's holding an ear of wheat in her hand, her left hand. And that's what Spica means, is ear of wheat.
Yeah, so this is really pretty. This, I had someone suggest maybe, was it Izabela? Maybe? Suggested that we put a windshield wiper on here to try and get rid of this. And actually, I thought about it, and that's a really good idea, and I could easily make such a system to do that. I just had to buy a spare dome and then figure out a way to attach it. And I could actually put a wiper system. Like, you know how the NASCAR systems, they rotate the camera through a washer. They rotate the thing. I wouldn't rotate the glass. I would rotate a wiper. One would wet it and on the way out, and then just go back and forth like on your car. Okay, let me minimize this now. Get us out of here. And here we are, back to our galaxy. I want to say hi to Daniel Twett, is it? How you doing? Agent 99, Barbara Feldman is 91 years old. Wow. Hey, thanks for offering that up. That's cool. No, Judy, I mentioned that wasn't the moonlight you were seeing. Let me bring it back for a split second here. It wasn't the moonlight. it was actually, let me back out. Okay, this is actually the lights of Phoenix out here, 80 miles away from the observatory, and that's really a testament to how sensitive this camera is, you know. So, and every 11 seconds we're getting a new image here, you know. We also make star trails, so like this is last night's star trails, right? As you can see, we have a lot of stars out there. This is really an absolutely incredible location. So, yep. Okay. This screen with all of its buttons is going to be available to you as on the like a website once we do it. It'll probably be on SkyTourLive.org. Once I figure out how to get the website off of being a local site and out onto my location. I've already talked to some folks about that. Lewis, we have the next observatory is in Benson. I got to tell you, if we built it in White Sands, we would basically have airplane traffic all day and all night, and then they'd want to know what we're seeing, because White Sands is actually it's a military reservation, so we wouldn't be able to put it there. I love your idea, though. Death Valley is actually not a good place for an observatory because the temperature fluctuation is too much, and it's actually at too low an altitude. We'd have to have higher altitude. This observatory is around 2,000 feet, and the one in Benson's going to be about 3,500. So we're going to gain some altitude. Okay, we're going to save this now. This is Messier 99. Let's save exactly as seen. Wowee, not bad. Can't wait to process that.
You want one more, or are you going to go to the Silver Streak?
Which one would you like to go to? I'm always up for suggestions.
91.
Which one?
Messier 91, I think. Let me look.
Okay.
Double check. Yeah, Messier 91.
All right, let's go
it's in the
find
same
it.
general area. Southern Coma Berenices in the Virgo cluster.
Okay, Messier 91. We will go there. Oh yes, that's quite a lovely. In fact, this will probably be. It'll be about the same size as the others we've been looking at, actually. Here's our field of view. You can see how big it's going to be. And you're going to see these other galaxies in there, too. All right, let's check it out. We'll go there, and we'll do that right now. There we go. Zing! Here it is.
I know you've answered this already, but it looks like we have a new arrival. Doomwalker 42 says, will you be watching the solar eclipse?
Oh. Yeah, I will be watching it. I won't be able to stream it, though, because I don't have the camera hardware yet. But thanks, Doomwalker. Thanks for coming. And I think you're subscribed, but if you're not, please do. We got plenty to show people. I don't have the camera for the solar telescope I have. But the solar telescope I have will allow us to see the prominences, flares, chromosphere, which I'll describe tomorrow when I do my stream about the sun and solar eclipses. Okay, so there we go. So I'm going to let that settle out. We're guiding now. And we're going to go to 25 seconds, which is 25,000 milliseconds. All right, that's good. And now we can live stack that. Drop out of our enhanced view. So many galaxies in here. This is the previous shot. Lubo in China, how you doing, man? Okay, there we go. Is this the one that looks like it has a steering wheel structure in it?
Kind of, sort of, yeah. I don't think it's the one that you're thinking of, though.
Is it a barred spiral? I'll have to look, actually. I got that right here. Okay, we have just the edge.
Yes, it is.
Okay. We have just the edge of M88 in here, which is right there. Think about this, guys. Within our galaxy, we have perhaps 100 billion to 400 billion stars. And there's more planets than there are stars in our galaxy. And we're looking at whole other galaxies, some of which are way bigger than our galaxy, some of which are a little smaller or equal size. And when we look at these galaxies, we could very well be staring at billions of other life forms and not even know it. You know, obviously these stars are in our galaxy, so they're all up in the foreground, and these galaxies here are way out in the far in the intergalactic distance away.
You say that's what do you call it? One on the right?
Oh, that guy is actually just peeking in. It is Messier 88.
Okay.
Yeah. Yep. I mean, we're so close to Markarian's chain. I mean, we got all kinds of galaxies here.
Yeah, M90, M89.
Oh yeah, and we have the Virgo
M87.
galaxy. Yeah, we have M87, the Virgo galaxy, which actually has the incredible black hole at the center. Of course, we can't see that. This is a very busy part of the universe over here, because these are all approximately the same distances, roughly. So they've all been interacting with each other for hundreds of millions of years. All right. So like this one here is 52 million light years away. This one here is 46 million light years away. This other one here in Markarian's chain, probably a little more distant. I've got to find out. Yeah, this is 60 million light years away. So they're all relatively close to each other, and from a galactic perspective, that's right around the corner. Oh, you know what we haven't done, Daryl, is look at Messier 87 to see if we can see the jet with this camera.
Sure. I didn't think the Virgo cluster itself would be up this accessible this early.
Yeah, that's pretty good.
Might as well. I mean, you wanted to look at galaxies tonight, in for a penny and for a pound.
Yeah, I'm going to, we're going to go to Messier 87 right after this. And we're going to do that right now. It's actually after 1 a.m. here, so I'm going to have to go to bed. I had to do some work for A&E today. I had to do a write-up on a bunch of different cases for them. Let's see, we'll save that. But I sent it off, so hopefully they won't have a problem with it, and I can sleep late tomorrow. Because we work on the weekends. Izabela asks if the universe is fine-tuned for life. I would say that I believe the universe is fine-tuned for carbon-based life. However, it's carbon-based life, though, but attacked with a vengeance. All right? If the universe is going to do anything, it's going to try to destroy life. The environments of the planets are the only place where it's safe for life like us. Okay, we did that. We got that. Alright, we're going to get out of that. And we're going to come back to this. We're going to go to Messier 87, which is the galaxy that the massive black hole was imaged by the event horizon. And that's a really large elliptical galaxy, so it looks like a big fuzzy ball. It may not look like much to you, but there is a absolutely incredible jet coming out of it. It's a radio jet, and you can see it visually, and the jet is a very, very high-speed stream of material coming out of the north and south poles of this galaxy. We're going to see if we can see that with this camera, which has nearly twice the resolution as the previous camera we had. And there is Messier 87 right there. So let's go up. And remember, we're still using what's called a hyperstar, a wide field. With the new telescope, we're going to get, our field of view is going to be more like this, and we're going to be able to see some really stunning vistas with this one we're getting. Okay, this is going to be I'm going to go 15 seconds. Now, okay. I'll do 20. Because I think that we're going to need that to see the jet. So here we go. Temporarily into the dark, my friends. We come from the dark. It's within that dark nebulae that the stars and the planets will have formed in the dark. So really, life came and sprang from the dark in the universe. It's pretty cool. Okay, let's get our first image.
Fiat Lux.
Oh, there we go. What's that?
Fiat Lux, I said. Let there be light.
Oh. Yeah, let there be light, yeah. Okay. Now, last time we looked, we figured that the jet was at the 2 o'clock position, I think.
Yeah.
So we're going to look again to see if it's there.
This is the biggest galaxy in the Virgo cluster, folks. It's a huge elliptical galaxy. Messier 87. This is the one the Event Horizon Telescope got the first image of a black hole from.
Yep.
Huge black hole in the center of the galaxy. In fact, the jet that Mark's talking about, which I think is maybe just barely at the edge of vision there.
I think here it is.
Yep, that's one of the jets emanating from the black hole.
And what we're going to do is actually try and dig into it by pulling away some of the brightness of the core. Oh yeah, look at that. There's the jet right there. See that little extra little piece sticking out, guys? That is the jet coming out of Messier 87.
It's still subtle, but I think it is a little better than the last camera was.
Oh, for sure. And it's only 5 shots in. If we let it go to 25 shots, then it's going to be really, really obvious.
Yeah.
And the thing is, we probably could also benefit from refocusing. Let's try, see what happens here. No. Temperature didn't change the focus value much, so the coefficient is okay. Let's actually zoom in even more. We'll see more noise, but we'll see this jet. It's pretty obvious. And let's even dive out more. Oh, you can really see it now, Daryl. See it?
Yes. Much better than the last camera.
Oh yeah. It's obvious now with this camera. The other one, we had to kind of look for it and hope we could see it. Yeah, very nice.
This is the general direction that our entire galaxy and all the other galaxies in our local group are moving towards.
Great attractor.
Is the Virgo cluster. And then the whole Virgo cluster and us with it are headed toward the Great Attractor too, which is farther to the southeast, I believe. Seems like you don't hear much about the Great Attractor anymore.
Yeah, I think that they're more focused on dark energy and dark matter in cosmology. Oh, that's obvious. Look at that thing now. You can't miss that. Let's go way in. This is 510%, and you can see the object here. Now, for those that are not astronomers out there, I won't be upset if you say you can't see it, but it is pretty obvious that there's a overabundance of material right here. The more we let it go, the more you'll see it. In fact, that's a good happy medium. Look at that. That right there.
Mm-hmm. There's a question going around in chat. Who said it first? Carl Becker. He read that this jet is traveling 4 to 6 times the speed of light. He says, I thought the speed of light was universal constant. That's, what do they call that? Superluminal motion. That's an effect. It looks that way, but it's not really that way.
Yeah, no, the speed limit of light, light speed is still the speed limit in the universe. So it's not actually going faster than the speed of light. And any YouTube videos that tell you it is are just proof that YouTube, you don't get your degree from Google. I can tell you that. You really, if you spend the time, you can learn a little bit more about it. So I'm not accusing you, of course. I'm just saying that, you probably saw a video online done by someone who's not as intelligent, or not as thoughtful, more likely, not interested in details, but wants clicks. And So I have a problem with them spreading false science. So that's kind of where I'm at with that. So now watch the difference. Look at that. Not bad. Yeah. And here's the thing. There's a lot of energy in this elliptical galaxy. And we also find in these galaxies like this that there's very little dust. In fact, very little gas. It's like they're all done with their star formation. And in a sense. And that's why when we see these big ellipticals like this, they seem to be an end state almost. So I think that's kind of cool. Welcome, Komang.
YouTube chat doesn't seem fond of posting as many characters as it used to let me do.
Really?
I tried posting a rather short passage earlier, and it said it was already too much. Thought it used to have a bigger limit. If I can read a quote real quick.
Yeah, go ahead.
What we were talking about earlier, where the jet appears to be going faster than it is, faster than the speed of light. In astronomy, superluminal motion is the apparently faster than light motion seen in some radio galaxies, BL Lacerda objects, quasars, blazars, and recently also in some galactic sources called microquasars. Bursts of energy moving out along the relativistic jets emitted from these objects can have a proper motion that appears greater than the speed of light. All of these sources are thought to contain a black hole responsible for the ejection of mass at high velocities. Light echoes can also produce apparent superluminal motion. And that rings a bell. What's it called? V808 Monocerotis or something like this, where they're seeing light echoes move quickly through a cloud around a star or some kind of an object. Anyway, I posted the link there for superluminal motion if you have an interest.
Where is it? In the chat?
Yes.
Oh, it's up there. Okay. Thank you. Okay, 26 exposures here. And we'll be able to see this jet with processing because it's overwhelmed by the sheer brightness. But by dropping it down, you can already start to see it coming out. Okay. Not bad. All right, we're going to save this one last time. Save exactly as seen. Well, that's it. That's Messier 87. That's the beautiful elliptical galaxy that the Event Horizon Telescope saw the black hole within. Remember, we also have a supermassive black hole at the center of our galaxy, too. The Sagittarius A. And that has also been imaged by the Event Horizon Telescope. All right. Let's go and zoom out a bit. Now, these are small galaxies. What I'd like to do is take us to one of the larger ones, but I want to see if we can get there easily. Okay, this is where it is. All right, last time we tried this, we had an issue, but we're going to try it again. And we're going to see if we can get there. telescope is going to go way up over the top. And let's hope that it doesn't yank anything or rotate anything the wrong way. I had that happen, actually. Huh?
Already west of the meridian?
Yeah, a little bit. Hey, look, we got it. Okay. This is going to be a lot bigger. There is Messier 82, the Starburst galaxy, and down below it here, just out of shot, is Messier 81. Let's see if it's actually in the frame. All right.
Izabela, this is the one you were asking about the other night, the Cigar Galaxy M82.
Yeah, actually, let me bring us down to 25%. Okay, so I'm going to put the Cigar Galaxy here, and Messier 81 will be there. I like a telescope that can point wherever you point it in the sky. It knows where it is. There we are. Okay, and then we'll head to the west a little bit. Pull us into the center. And both of these will be in our view, and we'll be able to capture them both. These will be the last objects for tonight. Mr. Django, you got a headache? Sorry to hear that, man. Izabela, thank you for putting the M87 link up there in the chat. Okay, let's do this. Yeah, the Sunflower Galaxy is really pretty, Curtis. Okay, I'm going to drop us down a little more. There we go. That's a good one. Go over one more chunk. Alright, so these galaxies in Ursa Major are much larger than the other ones we saw, so you're going to see a very big difference. Okay. Yes, Curtis, we'll check out the Sunflower the next time, yes. Alright. This should be good. Okay. When we start guiding, I will pull the trigger on doing this. I'll do 25 seconds. Alright, we're guiding. Off we go. And we'll get out of this. Our yellow indicator is almost full here. Let's see if our full width half maximum filter is set. Okay, yes it is. Like, oh yes, very nice, and it's still in there. We got the whole, well, I have the whole galaxy in there. Okay, we have both. This is really pretty. These are going to be beautiful, a beautiful shot. So let me drop this down to preserve our small star size. And go to about there. Alright, so let's now come back in and color correct. You'll see a subtle shift in the colors. And then process. This is nice. Okay, and then we'll move this in just a little more. Move this down just a little more. And now we'll close in on this. This is Messier 81 right here. I just had this mini fantasy that we're going to see in this next image a bright star in here, and we'll have discovered a supernova. Good night, Judy. Thank you for coming. There we go. I want to thank you guys for joining us for tonight. This is a really excellent night. And right now, in our view here, okay, we're up here in Ursa Major. All right. So we're looking up here. Here's the Big Dipper. And I think we're somewhere around here, if I recall. No. It might be a little west. Yeah, we're thinking about
81 and 82. They're up. The front two stars in the Dipper's bowl. If you go to the right, there's two more stars at a slightly greater angle.
Yeah.
And then there's one star. The one star is the nose of the bear. The triangle with the two stars to the right of that single star, those make the bear's head. And
Okay.
M81, M82 are up in that general area of the head, I believe.
Yeah, I'm pretty sure we could probably see with this little distortion from the dome here of this thing. But we should be able to see M81 and M82 in the all sky. Are these them? Daryl, are these them, you think?
I'm sorry, I was doing something.
Either these or maybe these.
Point them again.
These two or these two?
I thought they were a little closer to the head.
Okay. Well, it's a very simple thing to check, right? All we have to do is go here and look for our constellations. Oh, that's Ursa Minor. Okay. There's Ursa Major. Oh, they're way out there.
They're up above.
Yeah, so that in this view, they're down below.
Yeah.
Okay. Well, let's see here.
I guess.
So they're up here. So if we come back, okay, here is.
There's
oh,
Dubé and Merak right there.
Yeah, these guys, and so they're
Yeah.
kind of up here.
Yeah.
Oh,
Now, if
wait.
you go over to the
Maybe
next two
that's it.
stars,
Maybe that's M82 right there with that red.
there, go to the right. To the right and down. Stop. Stop. Go back to the left. Stop. Go straight down a little bit. Right about there. To the right, just a hair from there. Right about there, I believe. If you call that an upper star at the top of the bear's head, his ear, they're kind of above the bear's ear, I believe.
Okay. All right, well, very good. That's kind of cool. The fact that we could see that on the all-sky cam is actually pretty good. All right. I'm liking it. Okay, so we're going to back out of that. Okay. Let's minimize. Go check it out. What do we got? Wow, look at that, guys.
Yeah.
That's M81 right there. And if we look at M81, we get a little closer. You can see beautiful strings of stars in here. These are associations of very hot young stars called OB associations. You can see more star clouds in here, and these look bluish because these are young hot stars, so they're blue. The older stars are stars like the sun, G-type stars, K-type stars. That doesn't mean older in age necessarily, because you can be born a G star or a K star, but these particular stars are older types in here. Looks really pretty, man. That's really nice.
Is there a faint patch disconnected over at about 9 o'clock from the nucleus?
This right here?
Yes.
Yeah, that's always been there.
Okay.
Yeah.
I don't remember that offhand.
Hey, Doom
Thank
Walker,
you, Doom
thank
Walker.
you, man. That's very nice of you. Thank you, man. We'll keep it up because we can't stop. Now you want to see a real thing, Doom Walker, and everybody else? Check this out. Now we're going to go up. And as you go up, you're going to see Messier 82. And you're going to see like incredible hydrogen emission for this outstanding starburst galaxy, which is making stars at a prodigious rate. Oh, sure. Go back down. Check it out. Watch this. Look at that.
That's the cigar.
That's right. And this is the starburst galaxy. You'll see it has red above and below. And we're going to enhance that a little bit. Let me pull that out for you dynamically here. Now you can see that. Look at that. Isn't that crazy?
I think I've said this before. I seem to recall, I'd have to tear out some of my old astronomy books. Back in the days of film, I don't remember seeing the red stuff in M82 like we see now. I wonder if it's something different between film sensitivity and modern sensitivity, you know?
I'm pretty sure that's probably true. I took a photo of this in 1983 with a 24-inch Cassegrain. Okay, and I exposed it for an hour and 45 minutes, guiding it at the eyepiece for an hour and 45 minutes. It would have been a 3-hour exposure, except for the fact that I allowed the telescope to run into the ladder I was sitting on, and it eventually bent the ladder around me, pinning me into the wreckage of the ladder that I had destroyed.
I remember that.
You remember that, yeah. So yeah, but this stuff was not evident, but this stuff was. Look at that dark nebula in there. This galaxy is under siege. Something happened, probably related to the fact that it was interacting with Messier 81 down here. Okay, so something like that happened. Not sure what it was, but boy, oh boy, it was tough. It really did a number on that galaxy.
M81 doesn't look very disturbed, though.
No, it doesn't, but M82 and M81 are definitely galaxies that are interacting with each other.
Yeah.
M81 may be more massive. Maybe we're seeing the end state of an interaction. This might be a dwarf galaxy out here, which could have been the result of a collision between this galaxy and that one.
Mm-hmm.
That is just incredible.
Interesting to contemplate.
Yeah. Okay. Let me try this.
Lewis, they may have already, interacted at least.
Okay. This is M81 and M82. think about the sheer amount of energy required to start such star formation we're seeing in here. It's a starburst galaxy. That name comes from the fact that it's producing stars at a much, much higher rate than normally seen. And it's happening in these red areas. These red areas are ionized hydrogen and mixed with dust, dark dust. And you notice how disturbed the dust is in here. Remember the Edge-on galaxy we saw earlier? It has a nice line right across the center. Well, where's the line across the middle of this one? It's non-existent. This galaxy has been ripped asunder by something. And in the process of the shock waves caused by gravitational ripples, most likely, this massive bout of star formation has gone underway. Look at that. Let's try bringing this way in, do what's called a push, and then pull this in and see what else we can see. Okay, you can see kind of some stuff on the outside here. Alright, so we'll go back to this setup. That's neat. It really is a very pretty galaxy. This shows it a little better. You can see the dust and the starburst core going on here. Galaxy ripped asunder. And it could be ripped apart by Messier 81 here.
Yeah, Wiki says gravitational interactions of M81 with M82 and NGC 3077 have stripped hydrogen gas away from all three galaxies, forming gaseous filamentary structures in the group. Moreover, these interactions have allowed interstellar gas to fall into the centers of M82 and NGC 3077, leading to vigorous star formation or starburst activity there.
Now, where's 3077 in this image?
I think, can you go to Stellarium and back out a little bit?
Yeah.
It is close by.
It's close by. Close by. Is it the dwarf galaxy?
It's not the one we saw on the left, which does have a name, but it is in the neighborhood.
Okay. Oh, the Garland galaxy?
I'm not sure.
Because we're here right now. All right. Well, NGC 3077 is the Garland galaxy.
Yes. All three of those are gravitationally interacting, supposedly.
Yeah.
The interactions have pulled hydrogen gas from all three galaxies into filaments, and those filaments are falling into 3077 and M82. Mm-hmm. And that's what's causing the red glow in M82.
Okay. Oops,
sure is pretty though, isn't it?
Yeah, really nice. That's what I want to do. All right. Really nice. All right. Well, this is cool, and I'm going to save this now. We've got 35 shots here. M81, M82. If only I had spelled those right up there. M81 and dash M82. Excellent. Okay. Nice. All right. Well, there you go, folks. That was a really good night. I hope you enjoyed Galaxy Season with SkyTour Livestream and Daryl and I. This was a really good evening. I want to mention to you also that don't forget, tomorrow I'm going to do an eclipse special. Tomorrow I'm going to run that presentation for you all. I'll make that a stream. It'll be on the YouTube channel, so you'll be able to check it out. Alright, so let's bring this up. The camera's eye shows things very different from how they would actually appear. So it's pretty cool. Alright, so what we're going to do now is I'm going to say goodnight to you, and we're going to come back tomorrow. We'll reconvene and do the presentation. Alright, so you guys have a good night, and I hope to see you tomorrow. Hopefully you guys can all join me tomorrow during the afternoon, most likely. And we will talk soon. Alright? So have a good night, everybody.
Good night, everybody. Thanks for coming.
Absolutely. And for the new people, don't forget to subscribe. Check us out. Join us. Look at our Patreon. If it intrigues you, join the Patreon too. Alright? So we'll see you guys tomorrow for the stream on the solar eclipse coming up. So good night, everybody, and have a pleasant tomorrow, as Chevy Chase used to say. And if you go out, keep looking up, except while you're driving, as Amanda used to say. We got a lot of legacies with us. Okay, guys. Good night. See you later.
Good night.